So good morning students. So in this class we are going to discuss microbial degradation of xenobiotics. So what are xenobiotics? So xeno means new or strange. So xeno means new or strange. So xenobiotics are man-made substances. Man-made substances that are not naturally occurred. So xenobiotics are the man-made substances that are not naturally occur. Such substances are called as xenobiotics. So such substances are prepared for the agriculture purposes and industrial purposes. So for agriculture and industrial purposes, we prepare new substances that we call as xenobiotics. So these xenobiotics are also called as recalcitrant substances. Recalcitrant substances, which is recalcitrant means resistance to degradation. Resistant to degradation. So xenobiotic compounds are also called as recalcitrant substances which are resistant to degradation. So biodegradation refers to breakdown of substances with in presence of enzymes in vitro or in vivo. In vitro or in vivo conditions. Such breakdown is called as biodegradation. So biodegradation refers to the breakdown of substances in presence of enzymes, either it may be in vitro conditions or in vivo conditions. That is called as biodegradation. Next we go for sources of xenobiotics. Sources of xenobiotics. First one is petrochemical industries. Petrochemical industries. So chlorinated compounds, which includes chlorinated compounds and benzene molecules. So the next one is plastic industry. Plastic industry, which includes antioxidants and plasticides. Antioxidants and plasticides, which are coming from plastic industry. Next, pesticide industry. So which includes benzene compounds, benzene derived compounds. Next, paint industry. xylene and toluene compounds. Xylene and toluene compounds. Whereas other industries includes electrical industry, paper and pulp industry, electronic industry, paper and pulp industry, textile industry, etc. So that comes with the sources of xenobiotics. So petrochemical industries, so where we get chlorinated compounds and benzene linked compounds. Plastic industry, so which includes antioxidants and plasticides, and pesticide industries, which includes benzene derivative compounds. Paint industry, that is xylene and toluene compounds, and other industries which includes electrical industry, paper and pulp industry, textile industry. So these are the different industries which will be acting as a source for xenobiotics. Next, we go for different methods of degradation. Methods of degradation. So the first one is degradation. Which is conversion of toxic to less toxic compounds, that is degradation. Next one is detoxification. So this is conversion of toxic to non-toxic. So degradation is conversion of toxic to less toxic by breakdown of structural compound, complex structure into simple structure. So there is a breakdown of complex structure into simple structure, which leads to the toxic to less toxic conversion, that is degradation. Whereas detoxification is conversion of toxic to non-toxic components by chemical group changes. Next one is conjugation. Conjugation is attachment with or linking with other components, with other structural components. So making them intoxic or non-toxic. So conjugation is linking with other structural components, which makes the toxic to non-toxic, that is conjugation. Next, so changes in the spectrum of toxicity. Changes in the spectrum of toxicity, which includes dehalogenation, decarboxylation, dehalogenation, decarboxylation, methyl oxidation, and deamination. So these are the chemical reactions that change the spectrum of toxicity of the compounds. Spectrum of toxicity of compounds. So we can change the spectrum of toxicity. It is broad spectrum or narrow spectrum. Broad spectrum or narrow spectrum. So this broad or narrow spectrum can be achieved by different chemical reactions. Will occur at different structural places. That is, which includes dehalogenation, decarboxylation, and methyl oxidation and deamination. So these are the different chemical reactions that allows to change the components. Either they are broad spectrum showing broad spectrum toxicity or narrow spectrum toxicity. So this is the changes in the spectrum of toxicity. So if you go for, so these are methods for degradation of xenobiotics. So if you have degradation of plastics, we have different methods, which includes hydrolysis, acetogenesis, and methanogenesis. So these are the different methods for the degradation of plastics. Next, we go for degradation of PCBs, that is polychlorinated biphenyls. Polychlorinated biphenyls, which includes natural attenuation, bioaugmentation, bioaugmentation, and biostimulation. Biostimulation. So this is about microbial degradation of xenobiotics. So xenobiotics are the new or strange molecules that are man-made substances which doesn't occur naturally and which are prepared for agricultural and industrial purposes. Next, coming to biodegradation. So degradation refers to the breakdown of substances in process of enzymes, either in vitro or in vivo conditions. So So xenobiotics are called as recalcitrant substances. So recalcitrant means resistant, which shows resistance. So they are resistant to degradation. Recalcitrant substances. And coming to the sources of xenobiotics, we have different sources for the xenobiotics. First one is petrochemical industries, chlorinated compounds and benzene, which are coming from petrochemical industries. Next, from plastic industries, we have antioxidants and pesticides. Pesticide industries, which includes benzene derived compounds. Paint industry, that is xylene tolerant components, and other industries which includes electrical industry, paper industry, pulp industry, and textile industry. So these are sources of xenobiotics. Next, coming to the methods of degradation of xenobiotics. The first method is degradation. So degradation, which includes breakdown of complex structural molecules into simpler molecules. So which leads to the conversion of toxic to non-toxic. That is degradation. So the complex structure will be degraded or will be changed into simpler structure. That is degradation. Next, detoxification. So detoxification is conversion of the components with the change of chemical groups on the structure. So which leads to the conversion to toxic to non-toxic components. That is detoxification. Next, conjugation. So conjugation is nothing but linking with other structural components. That leads to the conversion of toxic to non-toxic components. Coming to changes in the spectrum of toxicity of the components. So which decides whether the component is broad spectrum toxicity or narrow spectrum toxicity. So dehalogenation, decarboxylation, methyl oxidation, and deamination. So these are the chemical reactions, so which changes the spectrum of the components, whether it is broad spectrum or narrow spectrum. So broad spectrum is having many ways to show its toxicity. That is broad spectrum. Whereas nano spectrum is limited activity. So this broad spectrum and narrow spectrum of the components can be changed with different reactions, which includes dehalogenation, decarboxylation, methyl oxidation, and deamination. These are the different chemical reactions in changing the spectrum of toxicity. Next, So coming to the degradation of plastics, so plastics which also comes under other substances of xenobiotics, hydrolysis, acetogenesis, acidogenesis and methanogenesis. So these are the different reactions which are used, so which meant for degradation of plastics. So plasticides and antioxidants coming from the plastic industry can be degraded by using different reactions, that is hydrolysis, acetogenesis, and acidogenesis and methanogenesis. So these are the different methods of degradation of that is plastics. Next, coming to the degradation of PCBs, that is polychlorinated biphenyls, which is coming from pesticide industries. So these are from pesticide industries. Polychlorinated biphenyls. So these are the main ingredient used in pesticides. So different methods for degradation of PCBs. Which includes natural attenuation, bioaugmentation, biostimulation. So natural attenuation is this so the action of microbial organisms to stop the activity of PCBs, that is natural attenuation. So the activity will be stopped by using microorganisms, that is natural attenuation. Next, bioaugmentation. So the degradation can be increased by the increase in action of microorganisms with the increase in microorganisms, addition of microorganisms, that is bioaugmentation. So bioaugmentation is nothing but frequent addition of microorganisms, that is frequent addition of microorganisms that will increase the degradation, that is called as bioaugmentation. So biostimulation is also nothing but the degradation which is stimulated by the microbial organisms. So this all comes with degradation of PCB, polychlorinated biphenyls, which is the important components of preparation of pesticides. So which can be degraded with natural attenuation, bioaugmentation and biostimulation. So this is all about microbial degradation of xenobiotics. So xeno means it is new or strange molecule, that is which are not naturally occurred components, and you can say it as man-made substances which are coming from agricultural and industrial purposes, which are used for agricultural and industrial purposes. So such components will be breakdown by using microbial organisms or by the enzymes which is secreted by the microbial organisms, either in vitro or in vivo condition, that is degraded, that is considered as biodegradation. So which way we see different sources of xenobiotics: petrochemical industry, plastic industry, pesticide industry, paint industries and other industries. Whereas coming to methods of degradation, we see degradation, detoxification and conjugation. Whereas changes in the spectrum of toxicity includes dehalogenation, decarboxylation, methylation and methyl oxidation and deamination. Next, coming to the degradation of plastics, we have hydrolysis, acetogenesis, acidogenesis and methanogenesis. So which is meant for the degradation of plastics. Coming to the PCBs, that is polychlorinated biphenyls, we have natural attenuation, bioaugmentation, and biostimulation. So these are the different degradation methods of xenobiotics. With this, we have completed microbial degradation of xenobiotics. Thank you.